Welcome to good afternoon. Welcome to JCSF Physics tutorial class. This afternoon we'll be talking about position, distance, and displacement. I still remain my humble self, Mr. Hupe JS. This afternoon we'll be talking about position, distance, and displacement. So we'll be dealing with this topic because it is very, very essential on the journey of physics. Because as we are dealing with the matter and energy, so we are dealing with the matter. So we must be talking about the position, the distance, and the displacement of the body of matter. That is the reason why the position, distance, and displacement are very important under physics. Without wasting much of our time this afternoon, let us start with position. Let us start with position. And when we talk about position, what are we talking about? So the position of a point in space. So the position of a point in a space. Let's know that this is a point in a space. So it's determined by the distance and direction from other points. It's determined by the distance and direction from other points. This is a point. We are talking about position now. So I'm trying to explain the position. So, and the position of a point in the space. Let's say that this is a point in the space. So to determine the position of a point in the space. So this is determined by the distance and direction from other points. Distance and direction from other points. Let's say that this is another point now. So the position of a point, sorry for the noise, I'm trying to control the noise. So the position of a point in space is determined by its distance and direction. So from other points. So let me use 4 cardinal points as a typical example to back up my lesson. Here is west, east, north, and the what? And the south. So in order to locate the position of a point in a plane, so either in the blackboard or the wall of a room or in a drawing paper. So it is very, very customary to do or to draw 2 lines intersecting at an origin, 0. So, and perpendicular to each other. So to find the point, I think you are trying to get what I'm trying to explain here. So what I'm trying to explain here is that in order to locate the position of a point, to locate the position of a point, so in the plane, it is very important to draw 2 lines. We have drawn the first line, we have drawn the second line, and they are intersecting at point 0. So they're intersecting at point 0, and also perpendicular to each other. And also perpendicular to each other. So let me try to use this as a typical example. Let me just put the drawing 2 vertical lines, 1 vertical line and 1 horizontal line. They are intersecting at point 0. So let's call this place, this line Y. Down will be minus Y. This one S. The other side minus S. So the other side minus S. So we are trying to talk about position. So to right of the page is called S-axis. From this side to this side, this is what we call S-axis. And the vertical line going up, so the page is the what? Is the Y-axis. This is the Y-axis and this is the S-axis. This is the S-axis and this is the Y-axis. So by convention, point to the right of 0 are positive. Point to the right of 0 are positive. Now, this side, they are what? They are positives. So, point below 0 are negative. The point below 0 are negative. That is why the point beside the S in the right-hand side of 0 are positive. The point below Y, which is minus Y, they are what? They are negative. I'll be trying to explain. So the position of any point, such as, so let's just take this for example. Let's put this place as P now. So let's just draw this place as P. Let's call this place S. So let's call this place let's just call this place R and put this place as Q. Do not forget, we're trying to explain position. So we are trying to explain position. Now, this S, this P, this R, this Q. So inside the cross intersection line that we just drawn on the board. Now, the position of any point, such as the position of any point, you know, here may be point, here may be point, here may be point, here may be point. S, P, R, Q. So they are just like points in this the vertical and the horizontal line that we draw on the surface. So the position of any point, such as P, is specified by two quantities or coordinates, the S and Y. The position of this P now is specified by two coordinates, the S and what and the Y. So to get, that is to get the position of this P in this cross-section line now. So this is determined by the two coordinates S and Y. So without getting the two coordinates S and Y, there is no way you can get this point, the position of this point P. So in this the cross line. So now, if this position, the position P is specified by the coordinates. So that will be, let me just, if this place is 0, let's put this place to be 1. Let me mark another point here to be what? To be 1. So let me mark another point here to be 1, to be minus 1. Let me mark another point here to be minus 1. So remember that the upper part is the positive. So now, if the position P is specified by the coordinates, let me say that this is a position of P now. Now, we draw a line from here now. We draw a line, meet here, then down here. I don't want this thing to be squeezed or confused, for you to get confused. We are dealing with position. Now, we want to get the position of P. So, in this axis. So we want to get the position of P in this axis, and to get the position of this the position of P on this axis, on these two axes, it is going to be determined by these two coordinates, S and Y. So remember that this is one in the line of S. To get the position, the coordinate, which is S area, is we have S1. Y1, S1. So S1, Y1. I just want you to just look into it. We are dealing with position. So S1, so Y1. So if the position of P is specified by the coordinate, so S1, Y1, so it means that the distance of P from 0 in the S direction is S1. The position of P, the position of this P from the S from 0 in the S axis, the position of P from 0 in this S axis is S1. While the position of P in Y axis is what? Y1. And that is what I'm trying to explain. the position of P in S axis is S1, and the position of Y of P in Y axis is Y1. So now the S coordinate is what we refer to as abscissa. So it is called abscissa. That is what we call the S coordinate. So the Y coordinate is called ordinate. Y coordinate is called ordinate. So it's called ordinate. S coordinate is called abscissa. Y coordinate is called ordinate. We are dealing with position. The position of P, so in S axis is S1, while the position of P in Y axis is Y1. So the position of P in Y axis is Y1. So the S coordinate is what we refer to as abscissa, while the Y coordinate is what we refer to as ordinate. So I hope you understand. So let me put some other example to illustrate the topic of position. So I'm trying to explain the position. Do not forget that I said that the position of a point in space is determined by the distance and direction from other points. So that is what position is. So it's determined by a distance and direction from other points. So, and that's what you're trying to explain here. This is the point 0. The position of P now. To decide the position of P now, we must start from this point. So, and we get it in this axis. We can also get it in this axis. The position of P in this Y axis is Y1, while the position of P in S axis is S1. So that is that. Let me put another example on the board so that you can get the clear understanding of what the position is. When we draw an angle like this, and one goes like this, and that one goes like this. So let's just call this place 70 meters. We should call this 70 meters. So this place should be 0. This place also should be 70 meters. So let's call this place to 70 meters. So we should call that place to 70 meters. Now we should label this place to be Q and call this place P. So we should call this place R. Do not forget that any moment you are dealing with any angle that you are given in the form of this, if you want to deal with them, so you have to draw your 4 cardinal points, because that will help you a lot in solving them. 4 cardinal points. Here is west. So here is west, east. So we have north and south. Now, by getting this one drawn, so it will be very easy for you to start locating the position of any of the angle on the or for any of the point, so on the drawn angle. So we can get the position, we can get the direction. Now let's try to look into it. Now, when an object moves, remember that this is zero, this is the initial point. So where they can start. When an object moves from this point zero to point P here, we can just say, according to what you say, that the object has moved in the direction of what? 70 meters. When an object moves from point 0 to P, or from point O to P, so we can say that, so it has covered 70 meters. You see the distance indicates how far the object has moved. The distance from where the object started the movement to where it stopped. So it's how far the object has what? Has moved. However, knowing the distance alone is not sufficient to tell us where or in what direction the object has moved. And you know the distance, that doesn't, knowing the distance does not okay, it's not only the one that is okay for us to know where or in what direction the object has moved. So for the reason, point R, so and point R and point S are also, let's say point R and point Q, let's say point Q. From point 0 for point O is also part of the parameter that you can also use so to measure the distance to indicate the direction of the body that moves from point O here to the point P, which travel at a distance of 70 meters. Do not get it twisted. So let me try to explain to you so you can understand what I'm trying to explain here. What we are dealing with is position. So what we are dealing with is position. So the board is not enough for me to, that is why if I show on the board, some things will be blocked. So we are dealing with position. And I said that when an object moves from point O or 0 to P, now the distance it covers is 70 meters. And this 70 meters show how far the object has moved. This does show how far the object has moved. So, and we said that this one alone is not okay to tell us or in what direction the object has moved. So it's not sufficient at all to tell us, so the distance the object has moved. So point R and also Q are also 70 meters from O. Point R and Q are also 70 meters from O. That is R and Q, they are also 70 meters from O. So we can also not tell which point is the final position of the object. So we can see that which point is the final position of the object, because the object, we can see that the object moves from point O down to point P here, covering 70 meters. The object moves from point O to Q, covering 70 meters. The object moves from point O to R, covering another 70 meters. So we cannot say which of the point is final position of the object. So very, very important to specify the direction in which a body is moving. Specify the direction in which a body is moving. That is why knowing direction is very, very important. Now, in this diagram now, if the body travels 70 meters eastward, so we are talking about eastward now, we are talking about from here down to the other side, and that is why I got the 4 cardinal point here. When the body moves, so 70 meters eastward, so its final position is at P. When you move from 70% from eastward, its final position is at point P. That is that position where it is reaching. a body must start movement from a point. So it must start moving from a point. And when it starts the movement from a point, it's going to attain a certain point here. That certain point to attain here is the position of the what? Of the body. The point is attained here is the position of the body. So, and that's what they are saying, that if the body in the point zero move, so in the eastward, travel 70 meters from the eastward, so in the eastward direction, then its final position is at P. And if northward, so the final position is Q. If it's southward, then its final position is at R. Just know that the movement of the body starts here from the point O. So, and wherever it reaches across, either in the north, in the west, in the south, or PRQ. So that is the body final position. So we can just know that with the direction stated in this, we can get to know the position of the object. So on the directions shown on the board, so we can get to know the position of an object. Just know that the object we start is moving from the point O, and whatever it gets here, either in the point Q or point P or point R. So that is the position of the object. That's the position of the object. So once again, I'm trying to say position as a point in space. So, and it's determined by the what? Its distance and direction from other point. It is determined by distance and direction from other point. So position is determined by direction and distance from other points. By direction and distance from other points. That is why we get to know the position of an object. We've got to know the position. So we can talk about the distance. We can talk about the distance. So the distance of an object now is measured by the movement of the object from its initial position to its position. That is where the object starts and where it finally arrives. Now, for instance, when a body moves from point O now to point B, which is the position. Now, the movement of the object from point O to the point P is the distance. Now, the distance is determined by the position and the initial point of an object. So with that initial point and the final point, so we cannot get the distance of an object. So before a body could run, so a body must start from rest. And how far the body moves to reach, let me say that this is A. Now this is a body A, which is at rest here, 0. And this body needs to travel from this point to point B. Now here is the initial position of the object A. And the object A needs to travel to come to this position, which is what? B. Now the movement of object A from this initial position to the final position is what we refer to as what? Distance. Now we can get to measure it through the speed and the time. Because the speed that the object takes to move from point A to point B, and the time taken by the object to travel from point A to point B. With that, we can get to know the distance of that the object covered. So that is distance. That is distance. Now, we can talk about displacement. We can talk about displacement. We can talk about displacement. 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 So when we talk about displacement, the difference between displacement and distance is that displacement is a distance traveled by an object at a specified direction. So a distance traveled by an object at a specified direction. That is what we refer to as displacement. So when we draw a vertical line, let me just draw a line that, okay, an object A travels from the west to east at point B here now, at a specified direction. So this is a displacement. So a displacement is defined as distance travel in a specified direction. Now, displacement is a change in the position of an object. So it's a change in the position of an object, and it requires distance and direction to specify it. So displacement requires distance and direction to specify it, because it deals with the distance travel by an object at a specified direction. So it in need of the distance and direction, so that it can be specified. So that is displacement. Now, let me try to look into the difference. Let's look into differences between distance and displacement. Distance and displacement. Now, let's try to look into the difference between distance and displacement. I will just have to explain this using this diagram. Then you can get to understand what I'm trying to explain. Do not forget that displacement is a distance traveled by an object at a specified direction. So the differences between a displacement and distance now is explained in this cardinal point. So this is west, east. And let me just put it this way. Let's say the body travel from west to east, 500 meters. And the body turned back again to travel back to west at the meter of 300. So at the meter of 300. Now, the distance covered by this body is 800 meters. Because the body starts from west, moves to the east, turn back, is moved to the west at the rate of 500 meters. It returns the movement back to the west and cover 300 meters. 300 meters to 500 meters, that will give you 800 meters. So the distance covered by the body now is 800 meters. But the displacement covered by this body is only 200 meters. The reason is because displacement deals with the movement of that body in a specified direction. Now, this body has moved 500 meters, moving 300 meters. So again, so this 300 meters will be deducted from the 500 initial distance of the body from west to the what? To the east. Therefore, the displacement of the body is 200 meters instead of 800 meters. So to calculate the distance of the body is 800 meters, but to find the displacement of the body is 200 meters. That is the difference. That is the difference between the displacement and the distance. Now let us look into some other examples. So to put more light into distance and displacement. A man let's say a man travels from a town A to another town B. So let's say through a windy road. So covering a distance of 300 kilometers. Covering 300 kilometers. Now, if the shortest distance between A and B is 240. When you mean A and B, here is where he started the journey and where he is ending the journey. If the journey distance between A and B is 240 kilometers. In the direction of the line AB. Now, let's look into this. What is the displacement? What is the displacement? Now, what is the distance? Sorry. What is the distance? A man travels from a town A to another town B through a windy road, covering a distance of 300 kilometers. He travels from town A to town B, covering a distance of 300 kilometers. If the shortest distance between A and B is 240 kilometers in the direction of the line AB, so it's supposed to be what is the displacement? Sorry. What is the displacement? What is the name by which the man traveled? Of which the man traveled? Now, normally from town A to town B, the man is supposed to travel at the point a distance of 300 kilometers. Now, if the shortest distance between A and B is 240 kilometers in the direction of the line. Now, this one is 240 kilometers in the direction of the line, while the 300 kilometers is in the normal direction. So we want to find the displacement of the body now. The displacement of this body will be 240 kilometer or 300, sorry, the displacement of the body will be 240 kilometer or 300 kilometer. That will be the displacement. It depends on the direction by which the man travel the distance. If the man travels the distance in the windy direction, that means the displacement of the body will be 300 kilometers. If the man travel by the shortest distance through the line, that means the displacement will be 240 kilometers, because the displacement is specified by a certain direction, a specified direction by which an object moves. Either the man moves through the line or it moves through the windy road. So it may cover 240, it will cover 300 kilometers. But the man must definitely move or travel to the time B in a specified direction. The specified direction in which the man traveled is what we refer to as displacement. And this can also be distance in this sense. In the case whereby the man traveled 300 kilometers to time B and also return back to time C, or maybe the man traveled to time B at 300 kilometers and then move from time B, so I move to the western world, so to time C at another 20 kilometers. If you have 20 kilometers to 300 kilometers, that will be 320 kilometers. In that essence, it is not displacement, it is distance. So why the displacement of such kind of thing will be 300 and also 20, but distance is what? 320, because the whole distance that the man travel is distance. Why the distance the man travel at a specified direction is displacement. So why the point by which a body sorry. So why a point in space by which a distance and direction from other point is position. Now, that is all you need to know about the position, distance, and displacement. The position, distance, and displacement. In our next class, we'll be talking about the work examples under this topic. So we'll be dealing with the work examples under this topic. So whatever concerning the explanation concerning position, distance, and displacement, that's what I've tried to hint into. In our next class, which is coming up next week, we are not going to waste any time. We're going to the work example immediately under position, displacement, and distance. So we can now move to motion. Thank you. My name is Hupe JS. Hope you enjoyed the class. Good day.